Okay, so welcome back everyone to the Fall Methods for Software Engineering lecture. So the last sessions that we had, there were basically two exercises, one where we were doing most of the work together in class, and then one where you were doing some individual work, which is also the homework. So now let's have a look at another area where SAT solvers can be applied. So we looked at propositional logic and SAT solving, and one main application that we had was in the area of security, and we looked at role-based access control systems and how to formalize constraints and check them for validity on a given role-based access configuration. And now we're going to look at a second topic that's another application where SAT solvers are quite popular, and it's analysis of software product lines. So question is, what are product lines? Has anybody heard of software product lines? Yeah, people from the generative development, they have heard about it, and software engineering, we also mentioned it, right? At least feature models we mentioned, yeah. Okay, yeah, so a product line, it's basically some collection of similar software systems. So very simple definition, and it's called a family of products. And they are a family because they have a shared set of software assets, which is common. And we also use a common means of production of these software systems. So, well, how do you produce software systems? Here, if you have a set of building blocks, you basically configure these building blocks to work together. And this configuration of how it works, this is common for all these products in your product family. And then you have a software product line. This doesn't work for all cases. Sometimes software is very different. And sometimes it's not even necessary because everybody just gets the same software. But you can imagine there might be some cases where you have software that is specific to maybe even some hardware that it runs on. And it's not the same for every customer. So you use software product lines to customize create new products for different customers. And the idea why we do this is to basically manage this development of the set of common products to make it more of the set of products to make it more effective than you would for each separate product. So if you, let's say, test those building blocks, make quality assurance of those, then you can imagine that you probably don't have to do that much work on the product that you build from these high quality building blocks. And that's the main idea. And one, very important thing is to do this throughout the software development lifecycle. So not only for the programming part, but also for the configuration, for the delivery to the customer, and maybe even for the maintenance, to still keep track of this for the maintenance, to not now suddenly treat it as separate products, but exploit that they have some common assets. So one of the main important things when you have, let's say, already some set of different software products in your company, then you have to identify which ones are the similarities, which ones are the differences, and is it worth it to extract this kind of family and this software product line representation, because you have to change somehow the process. And there's been a lot of research in how to implement this in different companies, and there's been some studies on when is it worth it, how many different products do you need, but it's always very specific to each company. Okay, so do you have any examples of software product lines that you might already know? So it doesn't have to be the most classical software products. It could be software combined with hardware. Just yeah. Okay, so yeah, we see quite a lot of answers here, which are quite different. That's nice. So let's look at here. It says Microsoft Office collection, Microsoft Office. So many of these sound like a one single product. So why is Microsoft Office a product line? So which are the different products that different users might use in with Microsoft Office? Okay, so these are different products inside the Office, let's say, family. But do these products each share a large common set of assets? So is there a big like part that is shared between Excel and Word? Yes? I don't know. Probably. But okay, so that's maybe slightly a bit of a stretch because people would usually use well, either one, and they would not use different variants. So I would not say that Excel is a variant of Word. So in the software product lines, you usually have different variations of the same product, and you might have hundreds or thousands of variations of that product. You could say that maybe Microsoft Office has some sort of software product line behind it because it might have to run for different platforms, for different CPU architectures. It might exist in different, let's say, product variants, depending on the license that you have. You might have the home version, which has maybe less features than the professional or the Office 365 version. So there, I would say these are variants of each other. So if you compare, let's say, the, I don't know, home version against the professional version against the 365 version or the version running in the cloud, I'm sure they share a lot of common parts of the implementation, and they are really different products. But that's not a very large software product line. So we might say with this interpretation, we could say it's a software product line, but it's definitely not a very large one because we don't really have thousands of different configurations of this thing running on different systems, I would say. SAP, yes, that's more of a software product line because they basically, for each company, they kind of tailor their own system. Of course, there's a lot of sharing between the different companies, some like common base system, I would guess, that is common to many installations, but then very highly customized. So you could probably say that's some kind of software product line. Autodesk, Adobe, these are, yeah, well, companies, right? And they have different products. So maybe again, very similar to the Microsoft Office family. I'm not 100% sure if it's more obvious that these are software product lines. Then what else do we have? Car industry. Where's the software in the car industry? On the assembly line, there's some software. Yeah. Okay. Sorry. Yeah, the control software. And the control software might be different based on the different integrated systems that they have, these ECUs, electric control units, right? So they all need software, and the software that they have deployed might depend on the other components in the car. And that's why, yeah, the car industry, they're actually a big player in software product lines because they have so many different variants of the software, and they don't want to develop a new software variant from scratch every time they build a new car or they build a different variant of the car. So even if you buy some regular car, you can choose a few features that you want to have, and this usually then also means that the software in your car will be different from the software in somebody else buying the car with different features, right? So that's another example. Amazon warehouse, order authentication and delivery. I would say there's probably not more obvious than in Microsoft Office, maybe because they also have different endpoints that they need to service. So they have different configurations of the software where it runs. Something like that. Okay, we will look at some more. Okay, close this now. Some more examples. So one example is in Boeing. So this is from you see these are slightly older because this is from a set of, let's say, success stories of early adopters of software product lines, of the software product line idea. There's been a lot of stuff going on in software product lines since then. But basically, they are manufacturer of airplanes, all kinds of different airplanes, different military aircraft, satellites, missile defense, space flight even. And you can imagine that they need a lot of software. So they have this bold stroke software product line, which was a operational flight program software. And basically, it was deployed in these different kinds of jets. And they wanted to they wanted to basically improve the quality, affordability, and also the timeliness. So how fast can they ship a new system, which requires new software? So they wanted to boil it down to what are the core components. They already had the software for these different jets, but they were mainly based on somebody created a software for one of them, then they copied some assets or recreated some assets, and they built a new software for a different kind of jet. And what they wanted to do is they now wanted to minimize the dependencies of the different components so that you can put the component on the plane without actually relying on exactly the type of GPS that it has, because the GPS might be different in those airplanes. So one thing is always to probably refactor the existing code that you have, find the commonalities, extract the common parts, and then you have these common assets, your building blocks for the new software. Then from these building blocks, you basically have to try to rebuild the existing software systems that you already had. So you take the existing software systems from these planes, boil them down to the components, try to make the components reusable, and then try to redeploy the software that's now based on these common components. And then later, you will never have to do that step again, ideally, because whenever you want to build software for a new system, then you try to build it from these existing components. Of course, you can imagine that you still have to maintain those existing components. There might be new hardware that you didn't foresee when you built your product line, so you might want to extend your software product line later. So you're not really solving the problem of maintenance completely, but you're solving the problem of having to redo everything over and over again. Another example, Danfoss drives. So they make some frequency converters that control speed, torque, acceleration, synchronization, position, and performance of electrical motors. And they have a lot of software. So before they used software product line engineering, usually they used the waterfall process model, where they wrote down all the requirements, the design, implementation, testing, and so on. So basically, you only reuse here in a clone and own manner. Anybody ever heard of clone and own? So clone and own means basically you clone something that exists, so you copy it, and then you own it by modifying it and making it your own. So is there any problem that you could see when you do this clone and own process? Because you basically take a similar product, you copy the code of that similar product, you do some modifications so it works for your new product. So the effort to add a new product to your family doesn't seem to be very high, right? So why would you need software product line engineering in any different way if you can just copy and paste it from some similar product? So this figure here gives some indication. In this figure, they show the number of defects after product line adoption. And you see it goes down a bit. So what happens if you have a software bug in one of your control software code pieces? You have a bug in one of the software products. Now, what do? Let's say I build this control software. Many of you copy it, modify it, and then I said, oh, actually, my control software had a bug. Sorry? Send an update, but how can I update it if you already modified yours, right? If I send you my updated code, you can't just reuse that because you did modifications to your code to make it work for the hardware that you have. So you would have to review my code and see, is this bug still in your code, right? And then if it's still in your code, you would have to tell everybody who copied your code, well, actually, there was a bug in my code as well. So very time consuming and very expensive, because if you locate a bug somewhere, you might have to fix it in many, many different variants, right, that you copied. So what happens if we have separated components and I have a specific component where I found a bug and you reused this component? So I'm going to fix the bug in my component and say, everybody, please reassemble their software because this component now has a bug fixed. Then you can just reassemble it and redeploy your software, and hopefully this fixes also any potential bug that might have been in your software that you reused from my components, right? So reusing components here will actually help you a lot in terms of the maintenance. And yeah, also you can imagine introducing new features probably goes a bit faster because you just built this common, you add the features maybe to an existing component and then you just redeploy it to all the other devices, right? So also greater development efficiency. Instead of copying everything and then going through it line by line and checking where do I have to make it specific to my product, you can try to configure which pieces do I want, and then what is the, let's say, specific part that I still have to implement. And this specific part should then, of course, hopefully also be localizable in, let's say, one component or one piece of code. Okay. And other ones, yeah, in the automotive domain, you might have different models of a car. And there has been some initiatives. So I don't know, maybe 20 years ago, cars maybe didn't have that much software, but it was rising. And then when they had tons of software, they realized also for different hardware products, well, let's try to reuse the platform. So they introduced platforms into the production. Also, not only the software, but also the hardware. And then you can have, I don't know, I think Volkswagen has multiple different cars that are based on the same platform. I'm not sure if they even shared with Audi or if they, I think they might even be shared with Audi and Volkswagen, that they use the same platform that they develop, and then they just put some different components on it. So the software product line, or in general, a product line can be seen in the automotive industry. And of course, there's tons of software in cars that needs to be maintained and specialized to the features of that vehicle that you're buying or using. So now the question is, what is a feature? I've been talking about features. There is some definition of features. So it's a distinguishing characteristic of a software item. Very, very general definition of feature, right? So the importance is this distinguishing, right? Because otherwise you could probably reuse the other software item. If there's nothing that distinguishes two pieces of software, very likely you can reuse just the same component. But here, there might be some distinguishing characteristics, for example, performance, portability, or functionality. But it could be also functional characteristics, of course. So it's usually a property of some product, which could be functional or non-functional. So non-functional would be these example here, how fast does it go, how long do you have to wait, how portable is that piece of software, and these would all be non-functional because you don't directly experience them, or they don't deliver directly a service to you as the user. So stuff like, performance. This is really, it's a nice thing to have, but it's not like, it gives you a specific thing that it doesn't give you if it's just a bit slower, right? And the functional ones, this would be, really that, I don't know, you have the automatic brake system or the follow to stop in a traffic jam, stuff like that. Other examples might be automatic backup or storage or some cancel button. These would be features that would be functional because you can see that it exists and you can interact with it. Okay, now in software product lines, we usually develop software product lines by mapping out the features that we have that we need in our family of products. And some of these features, they can be shared, and some of them, they can be individual. So usually to define a family of products, we define this family over a set of features. And then we will see what a product is. So the product is basically a subset of the available features. Um, and then you can have many different subsets, and these are all different products of the same product family. And in feature modeling, this is what we are going to look at. We're going to look at feature models. This is some modeling approach to describe the common, but also the variable features in a software product line. So once we have a set of features, we need to say, how can we assemble them to a product, right? Not every combination of features is already a product. So we also need to define the logical dependencies between the features. For example, if you want maybe the voice controlled start and stop of the motor, you probably need the entertainment system because that's the one that provides the audio interface for the voice control. So you have this kind of dependency between some voice controlled start and stop of the motor feature versus some other feature which might not look directly related in the beginning, but you need this kind of entertainment system because that's the one that provides the audio interface. Okay, now here's another example. This is a feature diagram, and we're going to focus on these kind of feature diagrams because they allow us to describe exactly what are the sets of features that we have and how can we assemble products from these features. So here the system is usually the top feature. So the things in these rectangles, they are the features. So we have the feature eShop, catalog, payment, security search, bank transfer, credit card, high, standard. Those are the feature names. And usually the kind of products, they are the root feature. We always have a single root. It's always a tree. And we have some special symbols here. So we have those circles that are filled in. We have the circles that are open, that are not filled in. And the same for these arcs here. These arcs can also be between multiple children. So yeah, if we have this kind of circle here, it means it's a mandatory feature. So whenever you have the eShop, you need a catalog. You can't go without this catalog feature because it's a child that says it's mandatory. This one is also mandatory. This one is also mandatory. But search, on the other hand, is optional because it has this circle that is not filled in. Then we have these arcs here. So payment has two children, bank transfer and credit card. And the arc is filled in, which means that it's a regular OR. So you need at least one of them to satisfy this OR. So you either need at least bank transfer or credit card, but you can also have both. So you could have also both payment methods because this OR is not an exclusive one. The exclusive OR, that's this alternative. So if you have an arc that is not filled in, it means it's an exclusive choice. So no matter how many children this arc spans, you must pick one, but you can pick at most one. So it's basically, you have to pick exactly one of the children. Whereas here, you can pick one, but you can also pick as many as you like. And then, so that's the diagram part. And then there's also some cross-tree constraints. So because this has to be a tree, so we are kind of restricted to certain constraints, right? We can say that this must be included, or we can include some of these, but there are other constraints that we cannot easily express in this visual format. So that's why we can extend feature models with cross-tree constraints that we basically write over the features. We say credit card implies high. So this means that we have to find the feature credit card. So if we ever include the credit card feature, we have to include the high security feature. And well, this then automatically excludes the standard security because it's an exclusive choice. Okay, so that is the set of features that we have. And these are the relations between the features. So now the question is, what is a product? To define a product, we basically always have to include the root of the feature model. And then this will determine what other features we have to include, which other features might be optional. So if we want to extract a product from this feature model, we have to make sure that, so basically the product would be a set of features, right? So here I have this set notation with the curly brackets, and then I list some features, and this selection of features must be consistent with the constraints given in the feature model, and it must include the root. So let's have a look at this first set here. So cat is actually catalog, just abbreviated, not the real cat. So this would be a legal product. We have an eShop, that's the root. So yeah, we have satisfied the root constraint. And then the question is it consistent? So if we have the catalog, if we have the eShop, do we also have the catalog? Yes, it's mandatory. Do we have the mandatory payment? Yeah, we have it. Now, payment says we need at least bank transfer or credit card, and we do have the bank transfer. Great. So this means we have satisfied this constraint. So let's move over here. Security is also mandatory. Yeah, and we have to pick one of them. So here we pick the high security. Yep, that's fine. And search, we didn't pick because search is optional. So that's fine. So this means that this first product here, that is consistent with all the constraints in the feature model, and it does include the root. So let's look at the second one. We switched the bank transfer with credit card, and we added the search feature. So again, this is consistent. Now, because we have credit cards, actually we have to look more closely at this constraint which mentions credit card. It says we need high security, but yes, we already had that, so that's fine. Some illegal product, eShop, catalog, security, high. So why is this not a legal product? It has the root, right? So this means that something in it must not be consistent. So which part in this product is not consistent? We don't have a payment, but it says here payment is mandatory if we have eShop. Okay, so that's why this one is not, so P3 is not a legal product. So then here, this one, yeah, we're missing the root, so it can't be a product of this feature model. This one here, the last one.
Credit card and standard.
Yeah, so credit card, but only standard security, which means that this cross-view constraint is actually violated. So yeah, these are some examples of legal and not so legal products. Now, another feature model, if we have a search engine, this might offer us an optional page translation. It might work for lots of document types, but HTML is a mandatory document type. Images and videos are optional. If we have the optional image, then we can select either GIF or SVG. We can search by different languages, Spanish, English, French, and we can take any selection of them, but that is, the search by language is optional, and page preview is also an optional feature. And then we have some cross-tree constraints. So if we want to search by different languages, then we need the page translation feature. And if we want the page preview feature, then we cannot support the SVG graphics format. Okay. Now, the different elements here, we have a feature tree, which is the node that represents the features. We have the edges, which are the relations, and they basically introduce constraints. And then we looked at all these different features here, what they mean. and then we have the cross-tree constraints. So some more examples of legal products. What would be a minimal one? Is this a minimal one? So we have search engine. This is optional. Those are all optional. We have to have document type. Yeah. And then we have to have HTML. So this is basically a legal and a minimal product because it takes really only what is necessary and nothing more. Another one, which is an illegal product, if we have the search by language, but we didn't pick any of the languages, then that is not a legal product because now if we include this, we need to include at least one of its children. Okay. But we're now interested in analyzing these kind of models. So there are two main ways of analysis that are done on feature models. So one is we want to check the correctness or quality of the feature model. This means that we're checking the model itself, whether it makes sense. So what could go wrong with the feature model? I mean, why would we have to check it for quality or correctness? What would it mean for a feature model to not be correct? I mean, yeah.
Some feature, maybe like we had to make the model appear in our model.
So this would probably be the configuration. So that's the products that are derived from the model. Yeah, that's actually, yeah. So here, that's this configuration relates to products. So everything we check about the products with respect to the feature model, this would be the second bullet. And the first bullet refers to actually checking the model itself. So yeah, I might like check this one and see is there anything missing, and that's then called configuration support, and that's the kind of second analysis. So this is very important. For example, when you configure a product, let's say you want to, I don't know if anybody ever thought about configuring some nice car, right? You click the components that you want, and then it tells you what's still missing, right? Or if you configure a PC that you want to have built for yourself or you want to build it yourself, then you usually also have to configure the products, and then it tells you, oh, you're still missing a main board or something. You bought this CPU, but it doesn't have a main board, so you still need the main board, right? So this is the configuration support for the completing maybe products that you have configured. But the first one is just analyzing the model here. What could go wrong?
Some part of the model doesn't make sense. Let's say the language support is in the part of page review, that would be wrong.
If the
so the three languages
yeah,
the children of page review, that would
okay, so that wouldn't make sense to us as humans, yes. So if the languages were different page reviews, okay, yeah. So kind of sanity checking, yeah, but that probably is stuff that a human has to do, right? So if we're now looking at automated analysis, or could I make other mistakes here? What happens if I add a cross-tree constraint that says if I have HTML, I can't have search engine? Then how many products can you configure of this product line? You can't configure any, because here it says if you have search engine, you need HTML, and then the cross-tree constraint says, oh, if you have HTML, you can't have search engine. This would be really bad, right? You would have an empty feature model, which doesn't make any sense. There could be other cases where, let's say you have another cross-tree constraint where I say, if I have HTML, I can't have page translation. Is that a problem? Can I have products? I can have, for example, this product, right? Search engine doc type HTML. This minimal product I can have. It just means page translation I can't have, but it's optional anyways, so I don't care. Yeah. Huh? Okay, yes. So here we have this cross-tree constraint that says search by language requires page translation, right? So this means that I can never include this, but then I also never can include this. Anything else? So basically, we have some parts of the feature model that can never be used. We could delete this part and the feature model would stay the same. We could delete this part and the feature model would stay the same. So these features that can never be included in any feature model, they're called dead features. And they're usually pointing to some, well, quality concerns, that something is wrong with your feature model because you probably don't want dead features in your feature model. It's like code that can never be executed because it can never be reached. You probably don't want that. So some of these analyses are consistency checking, where you even check if the model is inconsistent. So this would mean it's an empty feature model, like we mentioned in the beginning, that you cannot configure any product. So that's the consistency. And then the second thing would be finding dead or common features. So the definition of some dead feature would be that you can never include, you have a feature, but it can never be included in any legal product. And yeah, then it's kind of meaningless. And if something is meaningless in your configuration, probably means you made a mistake somewhere. Then common features are features that are shared by all products in the product line. Do you see any common features here? Doc type, yeah. Doc type is a common feature. Because it's mandatory. If you have a search engine, you need a doc type, right? So that's a feature that appears in every single product. There's no way around it. Search engine, yeah. So which other one? Search by language is actually optional. So we have an example of a product here which doesn't have it. So it's not a common feature because there are some products which don't have it. So I think, yeah, search engine, doc type, HTML. In this one, I think they are the only common features that have to appear in any. But sometimes it's not that easy to see these things. Yeah, then another thing which is maybe a bit more high level, that would be model entailment and equivalence checking of feature models. So let's say you need to do some changes to your feature model. Maybe you need to remove some dead features because they really are never appearing in any product. Maybe they previously did, but you changed some configurations, so you now want to remove them. And then maybe you restructure some of the subtrees, that you move a feature to another parent, and then you want to check whether you broke anything on your software product line. So let's say you want to see, is there any configuration that was existing before and is now no longer existing? Then you can check whether like one model entails the other. So everything that is possible in one, is it also possible in the other? That's something that you can check on the level of models when you have two models. So for this one, you need only one model for consistency checking and dead or common features. That this would be the, let's say, more simple ones. Model entailment is a bit more, well, it's also simple, but yeah, you need two feature models. Okay, so the configuration support, this is usually the most common is interactive configuration. Somebody says, well, these are the features that I care about, and then you suggest them other ones that they can still pick. So I guess in any configuration system, you probably have seen something like that. When you pick, I don't know, the AMD CPU, it tells you that you can only use those main boards that support that CPU, and you can't use the other ones that might require an Intel CPU, something like that. So basically, it will validate the choices and check based on the user decision what else can the user still do. And then another one would be the configuration completion. So let's say you really don't care what other features you get as long as you get the ones that you picked. So then you can just tell the system, well, give me any possible completion after this partial selection that I made. Okay. now the question is, how could we support these feature model analysis? Now this is, yeah. Do we need to ask this question? Or should we just, yeah. Okay, you don't have to type it. Anybody has an idea of how can we support feature model analysis? What tools might we use to support these kind of analysis? AI? Maybe, yeah. Can we use a tool that we already learned during this lecture?
Maybe.
Stat solvers. That's a great idea. Yeah, let's try to use stat solvers. So what do we need to do to use stat solvers? We need to translate the feature model into propositional logic, right? Now, we always have this kind of challenge, like we had with role-based access. How do we start? What are the variables? So now the question is, what do we want in the end, right? A propositional logic formula is an assignment to the variables. If we, let's say, want to write a formula that tells us all the valid products, then a solution should be a product, maybe. So how would we have to model the features so that the solution to a such problem is a product in the feature model?
They being the mandatory.
Okay, so the mandatory and stuff, that's already the constraints that we have to add on top of. But what should be our variables? If we have this feature model, that's a bit large. Should we do this one on page 9? So this feature model, how would we, what would be the variables for this?
Like eShop and catalog.
Okay, yeah, so the features. For example, the features. So where's my, yeah. So let's say, let's do this as a comment. Features of the feature model are variables. Okay. So let's start with, that's already a lot. Okay, let's start with eShop. Now, if I just have eShop and I check for satisfiability, then it tells me, yeah, one satisfiable solution would be include the eShop. But it's a very, very small feature model, right? So let's at least create one where we add this, maybe this first line of features, right? So how would I add this first line of features? So how do I say that catalog is a part of eShop? So let's write that down. So let's write down, I'll write mandatory part of eShop, yeah.
Catalog implies eShop implies.
So which direction? eShop implies catalog. So now, whenever I have an eShop, I also need a catalog, right? Okay. Let's just make everything lowercase, otherwise I'm just typing it wrong. So the reason why we have eShop twice is because I misspelled it. And that's why we have two eShops, which is not what we want. Yeah, now we have it once, okay. So how do we do the next one? The payment one? The same, right? So I wonder, do we need the ends or can we just write the lines? Let's try. So eShop also implies, what was it, payment? Okay, we need the end. and security. And there was one more, search. That wasn't mandatory, right? So, what do we do? This is not mandatory, right? So, sorry? Or what? Doesn't like that? With an or, okay. Search or not search. Let me just. So eShop implies search or not search. What is that even? That's a valid formula. So it's always true. There's no way to violate this. So why is that always true? We have search or not search, which is a valid formula. It's always true, right? You either have search or you don't. So nothing said here. And we say eShop implies true. But this means that eShop, if it's false, then of course it implies true, because false always satisfies the implies. If it is true, then it also implies true, right? So yeah, this is really this formula. We don't really, it doesn't make sense to have it. Okay. So what do we do? Well, not this formula, right? So yeah, let's remove it. And then let's look at some products. Yeah, we have to. Okay, so now we don't have search, and we'll probably never get search, right? What do we do? Is there anything else we know about search? So how do we say that it's optional? Is there nothing that constrains search? You can just pick it or you don't. I mean, in this case, it's really a bit tricky to see, but there are some rules that are in feature models. So, for example, could I pick? Is there any restriction for me to pick bank transfer? In general, or if there was a child feature of search. Let's see if we have one example in the other one. So, oh, we really don't have an example for this. That's a bit unfortunate. Let me draw one. So we have. This doesn't really work. Let me. Let's put this one. So that's the. I don't know. What are we modeling? Or let's model coffee. Coffee might have optional sugar, and sugar, or let's say sweetener, because we might have. Doesn't. Sweetener, and then we might add. What I want to have a chain of two, so I might add. What is like? Okay, let's say I want something sweet in my coffee, and then one option would be sugar. But sweetener is also something I could add. So let's say we have optional sweetness in our coffee. And we can achieve that maybe with sugar. Oh, something is wrong with the, or with sweetener, right? There are those kind of sweetener pills that we can put in our coffee. Now we probably want to make all of these, yeah, some shape like that. Yeah, it's not, I should have brought, well, I did bring the camera, but well. So let's say, now that's all optional, right? Maybe that's not the most realistic, but yeah, let's say that's a model that we might have. So if we want our sweetness, we have maybe an optional sugar that we add, or sweetener. Okay, so these are all optional, like in our example, right? So is there anything that the sweetness relies on in this feature model? Not really, right? We can, because coffee is there anyways. We can just configure sweetness by either including it or not. So we don't really see any constraint that we need for sweetness. Do we need any constraint for sugar? It's the same, right? I have sweetness and optional sugar. Is there anything that sugar relies on? Yeah, we need sweetness. So we can't have sugar without having sweetness, right? So a child feature always requires their parent feature. Otherwise, we can't include it. And it's not so obvious for sweetness itself because, well, that always requires coffee, but coffee is the root, so that's mandatory anyways. But actually, a constraint that we would need to add is that the child feature always requires the parent feature. Here we just had that we had these constraints that eShop requires catalog because catalog is a mandatory child. But actually, the first thing we could do is we could add that every child feature requires its parent. So yeah, then we would basically turn all these around. We would say catalog implies eShop, and we would have that payment implies eShop, and we would have that security implies eShop. And now finally to the one that we have been doing all this for, that search implies eShop. So that's the yeah, important one. Now we can have a selection of well, all the features, which is fine. We didn't really check whether this makes sense, right? Because we now have an arbitrary selection of features. And yeah, so is this the first line of the feature model? Let me put back the feature model, which was on page 9. Yeah. This is the first line. eShop, catalog, payment, security, search. We have all of these. Most of them are mandatory. Search is not. So how do we now maybe check? So what are possible products that we can have, or what are products that we cannot have? Are there any products that we cannot configure? From just the first line. So imagine the bottom here didn't exist. Can we have a product configuration eShop that has search and nothing else? No. Should we check this against our feature model? Okay, so now I'm basically writing here and that we have a valid configuration, right? So how do I say that something is a valid product? I simply write it down, right? I say we have a product that has eShop and not catalog and not payment and not security, but we want search, right? So this is I'm writing here down the constraints for a single product. And it says it's an unsatisfiable formula. So if I would only take this formula and check it for satisfiability, I should get exactly the product that I was configuring, right? Yeah, I get exactly the product, which has eShop. Oh. What did I do wrong? Oh, it's validity check. Yeah, sorry. Yeah, we want the satisfiability check. Great. Yeah, so eShop, search are included and the rest is not included. And we see that this is not satisfiable. So, well, why not? Because simply, if we have eShop, we require catalog, right? So that's what's written here. So this means that we can already check products, and if we could go through all the possible solutions of this formula, we would get the different products that we can configure from our eShop. So let's say I want the completion of my product. How would I complete a product where I have the eShop and the search? Or just say I want the search feature. Now, how do I complete my product if I say I really, really want the search feature and I don't care about the rest? How would I do that? So let's delete this one first because this, yeah. So how do I do that? How do I ask this tool to complete my online shop when I want the search feature? Sorry?
We include all the mandatory features with search.
How do we do that? Sorry? eShop implies search. That would make search mandatory, right? And because we have eShop mandatory, yeah. But let's say I want to just give I want the search feature, right? That's maybe theoretically the same as you mentioned. If you have eShop implies search, that's the same as if I write search because eShop is true anyway. So if I write true implies search, that's the same as if I write search is true, right? So I want search and I don't care about the rest. Go to run it and it tells me this is a valid completion of the rest. Just take everything and that's a valid product. So I can now complete my products. If I say I want a product where I have a payment functionality and I don't have the search functionality, I can hit run again and it's going to complete this product for me. And that's the complete product. It's going to tell me all the other selections of features that I have to do. Okay, great. So that's the first part of the feature model. How do we do the more interesting ones? This one, bank transfer, credit card. What do I include? So we have now, what formula do we need to write to also support bank transfer and credit card? So this stuff was to play around, right? Now, and this thing we saw we don't need. So let's continue now with somebody said payment implies. Okay, and that's just to make it more readable and avoid any issues with the strength of the operators. So we say payment implies bank transfer or credit card. Does that look fine? So we have payment and we selected credit card and not bank transfer. Great, that satisfies our formula. Okay, anything else for fully supporting this? Let's do the security. How do we do the security? Yeah.
If bank transfer and credit card both are one, then also it will be true, right? But it should not be the case.
But for this one, it's fine. The or is fine. This one is the or that can include as many as we like. But now your comment is valid for this one. Here we can't simply write or because this is the exclusive alternative. So yeah, how do we do that? Let me just check. There's this README. I just want to check whether they have an exclusive or. If implies or and not basic. No, we don't have an exclusive or, right? So the syntax doesn't have our exclusive or, so we need something to just encode our exclusive or. So first, yeah, what do we need to say this security high standard thing? Okay, so it implies high and not standard, or not high and standard. So we simply list all the possible options that we can have, right? And we put this in nice parentheses, and we put an end here. And we get another solution, right?
But we also have to add cross constraint.
The cross-tree constraints. Okay, so let's first check. Do we have high and we have security? We have high. We don't have standard. Looks good so far by doing a single sub check, right? Yeah. Okay, and then we have cross-tree constraints, right? So yeah, let's add that also. What were the cross-tree constraints? Credit card implies high. Okay. How do we do cross-tree constraints? Yeah, we just try to write this thing down, right? No. These suggestions are not so helpful, right? How did I write credit card? Yeah, like that. Okay. Credit card implies high. Anything else? Yeah.
I think the children bankruptcy credit card high standard also imply that they have merit. I think you have to add that too.
Why? Let's check. Wait, let's run this and see if it's still satisfiable. We have credit card and high security, yeah. And then you said we forgot something. We forgot. Can you say it again? What did we forget?
That the children, the leaf children need their parents.
Yes. So we basically we can only include high and standard if we have security, right? So we forgot this. Now that we added more features, we basically need to add also their dependencies. So high implies security, and standard implies security. And we had other ones, the ones for the payment methods, right? So bank transfer implies payment. So and we have credit card implies payment. Yeah. Very good. So yes, we do need those. Here, very likely, they are not necessary because the parents are always included in any product. But we can't really rely on that, right? If we want a systematic way to translate this, then we need to put these constraints back, right? Now they are trivially true, and if I could maybe even delete them, but let's keep them because we really want to know, we really want to make sure that we have a systematic way of translating this feature model to a SAT formula. Okay, now let's check some of these things, right? Should we just sanity check that what we previously determined about our feature model, that this is really true, right? So should we check that this is a legal product? How do we check this? So this was eShop and catalog and high. Now, if I hit the run button, there are some variables that I did not mention. This means it's going to try to complete the product based on the constraints that it has. But here, actually, because it's written as a set, we know that some things are not in this set. This we didn't encode in the formula yet. So what do we know is not in this set? Search is not in the set, and which one else? Standard is also not in the set. Yeah, standard is also not in the set. So let's add them. So basically, and not search and not standard. Anything else missing from the set? Credit card. And not credit card. Okay. Now I clicked run. We have some update here. eShop, catalog, payment, security. We don't have search. We have high security, no standard security. We have bank transfer, and we don't have credit card. So this, what does this mean? It's basically exactly what we said here, right? But now we know that this thing, together with all the constraints of the feature model, is still a solution of our formula. And that means that this is a valid product. So we have confirmed that this product is really a valid product. Now let's look at one that is not. So eShop, catalog, security high. Now eShop, catalog, we said security and high, and everything else basically has to be negated, right? Because it's not in this set down here of product 3. That's the one we're checking now. And what would we expect if I hit run? Should say unsatisfiable, right? So let's hit run. Unsatisfiable. Great. Very good. So probably our translation here makes sense. So let's look at the what's behind this question mark. Those formulas. So we said R is the root feature. Let's look at our translation. Can I put it again side by side? Try. Yeah, so this is our formula eShop, right? So that's our line 2. With this R, yeah, okay. Then if a parent is parent of a feature, then this means that the inclusion of the child implies the inclusion of the parent. So that's exactly this thing that we were first missing, but then we said every child feature requires its parent. So now, of course, this number of constraints basically is for every feature that is not the root, we need one of those constraints because the root, well, doesn't have a parent, but every other feature has a parent. So this is like the number of features formulas that we need to include. But they're all very short because they're just between the child implies the parent. Then we said if feature M is a mandatory subfeature of the parent, then it says the parent implies M. It's one of the first ones that we developed, right? So eShop implies catalog, eShop implies payment and security, exactly this formula. Then we said if it is these, well, or features, right? So you can select one or up to n out of all the child features. Then we said it's basically the parent implies one of the children, or not really exactly one, but that's basically this children of payment. This was the selection where we said, yeah, either bank transfer or credit card, could also be both. And then we have this one-to-one multiplicity. So that's basically you have a bunch of children, but you must choose exactly one. So lower bound of your choice is 1, and upper bound is also 1. So you have to choose exactly one. Here, the lower bound was 1. You could choose as many as you like, up to n, all of them, right? But that's the exclusive one. So we had that for the security. You either have standard or high. So here it's basically, yeah, written as 1 of n. And that's exactly what we encoded here, 1 of n. So one of the children is written positive and the other one is negated, or all the other ones are negated. So if we would have multiple, we would have to negate, well, all the other children, right? Okay, and then cross-tree constraints, already Boolean formulas. So now we have a translation of feature models to propositional logic, and we already saw some of the analysis. The analysis that we used were, yeah, we did the configuration support. So we had a partial feature selection and we completed it. We confirmed some choices here. So that's just basically going it through it step by step, how to encode it. That's the encoding for this feature model. We did the encoding for the other feature model from slide 9 manually. So this one is yeah, very similar. And now we said we can do correctness checking and configuration support. So we already looked at the configuration support, but now let's look at the correctness checking. So how do we check whether some feature F is dead? So dead means that it doesn't appear in any product. So yeah, how do you check whether some feature is really not in any product?
It's like interceptor.
Yes, so with our encoding, right? So the encoding that we did, we want to reuse that, but now we want to check whether feature F is a dead feature. Okay, so let's look at some of the answers. So if it says here the model is valid, even if the feature is not included, if valid is in the context of propositional logic, then it would mean that any assignment or any selection of features would satisfy it, which usually is not the case because we have some constraints, right? So this would mean it doesn't have any other constraints, which is not really realistic. Then this one checking if there are no cross-tree constraints and other dependent features to that dead feature. That's more like a syntactic way, but we don't see cross-tree constraints really anymore in our translation to SAT. So we could do that maybe if we have given the feature model on paper and check that. By checking satisfiability of our encoding, this just means that there are some products, right? But we don't know whether this particular product is dead or not. Then if they do not belong to a legal product, exactly. But how do we do that? There could be, how many products could there be? If I have 10 features, then I can basically, if there were not many constraints, then each feature could be true or false. And this would basically give me 1,024 different products. So I probably don't want to check every one of them to see whether this feature is in there or not. So this one is interesting. Set the given feature to false. What happens if we say that this feature is false? And then we check satisfiability. We check validity. But validity, that's something very similar to here. So if we set the feature to false and check validity, then this means that if this feature is false, there are no further constraints, which is very unlikely because the root is always included. So this means we wouldn't have validity because we can't set the root to false. So validity is not really the right one. Any other? Child implies parent can be eliminated, still a valid product. So, okay, let's not try 0. Let's try 1. If I say I want my dead feature to be included, that's basically I set my dead feature to 1, right? And if I do find a solution, is my feature dead then? No, it can't be dead because then I have a valid solution with my feature included. If I set my feature to true and the SAT solver tells me it's unsatisfiable, is my feature dead? Yes, then it's dead because if there was a product where my feature was included, I would have found it using the SAT solver. But if the SAT solver says I can't find any, it means there is none. So if I have a dead feature and I set it to true, I should have an unsatisfiable formula. So yeah, it's as easy as that. How do we check whether a feature is common or mandatory? The solution was on the slide already, yeah? Yeah. Yeah, set it to false. And then if we have a solution, we know that it's not mandatory, that it's not a common feature because we have found a product where this feature is not included. But if we have unsat again, we know that there is no way to exclude that feature. So it is a common feature. Yeah. So dead and common features, they're actually very easy to check, but we have to do this kind of trick by relying on unsat rather than a solution. So because the SAT solver promises us that if there was a solution, it would find it. That's something called completeness. And completeness is really, a nice feature of some decision procedures because with completeness, we can check these things like dead or common features because it promises us that it will check all possible combinations. Okay, how do we complete the partial configuration? We already did that. We gave the stuff that we know we want and we let the SAT solver do the rest. Yeah, so 1 minute very quickly. There's, of course, lots of this stuff in practice. There are different companies and there are many commercial products that implement software product lines. there is one very popular and very well researched language that's kconfig. It is also used to configure the Linux kernel. So they have, I'm not sure how many configuration alternatives they have, but they basically have, there could be more Linux kernels than atoms in the universe that you could configure. So basically, it's a huge space. They haven't, I think there is no full formulation of that in SAT solvers, but people have done partial formulations and they found a lot of dead features in the Linux kernel, for example, using SAT solving. And they also find some abuses of reverse dependencies. And they were able to fix tons of different configuration files of the Linux kernel and find real possible threats to the stability or security of the kernel. So that's very good results also on a practical level. And you can look at the exact definitions of what people have done and other works that are linked on this website. So if you're interested on a really, let's say, very large feature model, then this stuff is there. So we said to analyze feature models, we need to translate them automatically to SAT, right? We now did this manually, but actually we want it to be automatically done. So we need some readable format for the feature model files because we need to read them to then be able to translate them into SAT formulas. And we need then some algorithm to actually encode our checks that we want to be done. And this is the stuff that we're going to do in the next session, or that you're going to do. So you did some manual encoding for the current homework. And then the next homework will actually be to try to automate this encoding. So you will have some partial implementation, and you have to complete this implementation so that it does exactly the stuff that we now did manually, that it does it automatically so that we can analyze any feature model that we want. Because right now we could only analyze the ones that we manually translated. Okay, so see you in the next session.